Look how fast that bottle is going down that ramp. I think it. I think if a wheelchair user were to go down that ramp, it will be quite dangerous.
Yes, I think it's quite dangerous for wheelchair people. Maybe because it's too stiff. The angle of the ramp is quite off.
But how exactly can the angle of the ramp affect the speed of the object going down?
To know that, we can do a mock-up experiment to represent the real-life situation. Let's go!
Before conducting our experiment, we first ask ourselves a simple question. Does the angle of a ramp really affect how a ball moves? The purpose of this study is to investigate the effect of ramp angle on the rolling motion of a ball. In everyday life, inclined planes are commonly used in wheelchair ramps, loading docks, parking garage, and playground. Choosing the right ramp angle is important because it affects both performance and safety. A steeper ramp allows an object to move faster and accelerate more quickly. However, excessive speed may make the object difficult to control and increase the risk of accidents. On the other hand, a shallower ramp is generally safer, but the object may move more slowly and less efficiently. Therefore, our study aims to answer two important research questions. Does increasing the ramp angle always increase acceleration? And which ramp angle is most suitable for real-life application? To answer these questions, we conducted an experiment using three different ramp angles, which are 15 degrees, 30 degrees, and 45 degrees.
To do this experiment, we tested a few apparatus. First, any blackboard to imitate the characteristic of a ramp, ball as a rolling object, protected to measure our angle, and timer to record the time taken. Since we are trying to find which angle is the safest for wheelchair user, we are going to find the speed for different angle of the ball falling. After a thorough discussion, we have decided that since angle plays a crucial part in this study, we'll use projectile motion. But first, what is projectile motion?
What is projectile motion? The definition is a body that is projected at an angle to the horizontal and moves under the action of gravity. For example, a ball is dropped from 5 meters from the ground, and under the weight of the gravity, it falls down to the ground. Also, projectile motion means that free fall accelerating is constant over the range of motion and is directed downward, and the effect of air resistance is minimal. Now, for data and info gathering, we will be using the formula of Vy equals Uy minus GT Vy. Next to that is the table that shows the angle and time taken. There is three data included where angle is 15 degrees downwards and 75 degrees upward. What this means is, imagine a right triangle and the angle of the top of the triangle is 15 and the other angle is on the bottom, which is 75. The other data is 30 degrees downward and 60 degrees upward. Then 45 degrees, because both upward and downward are the same. Next, time taken means the time taken for the ball to go from the top of the ramp to the bottom part, and the times are 1.38 seconds, 0.8 seconds, and 0.67 seconds. Now for number 3, interpretation. We have another table which shows angle, time taken, and a new column which is speed. We get speed from using the formula in the previous slide. Thus, we got negative 13.54 meter per second, negative 7.85 meter per second, and negative 6.57 seconds. As for why all the speed is negative, it is because the direction of the speed is downward. From that, it can interpret that the angle of a ramp plays a big part in the speed of going down said ramp. Also, that the lower the downward angle, the higher the speed of the projectile.
To wrap up our presentation, let's look up at the definition of conclusion of what happens when a wheelchair ramp is constructed with oval step incline. When this happens, it creates immediately physical barrier and significant liability. Let's break down the two main point consequences of this design flaw. First, we create the immediate safety hazard. An angle that's too sharp directly increase the risk of a wheelchair tipping backward during ascent. On the way, it increases the danger of wheelchair rolling out of control during a descent. Second, it leads to physical exhaustion and exclusion. Manual wheelchair users require immense physical exertion to climb steep slopes. This extreme physical demand frequency render the ramp completely usable without assistance. Ultimately, construct a ramp with steep incline fail the very people is built to have, replacing independent with physical barrier and safety risk. Thank you.